Hello everyone, welcome to this video. I hope you're all doing well. This is the continuation of this problem solving series from CMI PYQs, and today we'll touch upon algebra and specifically the part of polynomials. Now, polynomials is a very interesting topic, especially because it is in the intersection of algebra, coordinate geometry, and calculus. Right, so coordinate geometry because you can talk about the graph of it and everything. Calculus because increasing or decreasing or how many roots is related to the derivative properties. And yeah, it's a very interesting thing. So without further ado, let's start. Just resize myself down here. I hope that's fine. All right. So maybe go a little bit bigger. All right. Here we go. So let's go first question. Pause the video, give it a try. Okay, the question says this complex number I minus 3, right? I minus 3 is a root of this polynomial and the polynomial has real coefficients. Now, since the polynomial has real coefficients and one of the root is complex, that means the conjugate of this complex has to be another root of this polynomial, right? So always remember, I hope you should be knowing this, if a plus ib is a root implies a minus ib is also a root. When does this happen? Whenever coefficients are real. All right, if the coefficients are real, then if this is a root, then this is also a root. So in our case, since I minus 3 is a root, implies minus I minus 3 is also a root, right? So we can write p of x as x minus I plus 3 into x plus I plus 3 into some ax square plus bx plus c, right? Because it is a degree 4 equation, degree 4 polynomial. So that is there. So if I multiply this, what am I going to get? So x square and then the sum of the roots, so plus 6x plus the product of the roots, which is 9 minus 9 plus 1, so 10, right? This into ax square plus bx plus c. Now this has to be equal to what? The given thing, 3x power 4 plus 10x cube plus ax square plus bx minus 30. What do we need to find? Find the other roots. We don't need to find ab. We are not interested in that. So to find the other roots, we need to solve for this particular equation. So we need to find what a, b, c are. So immediately if you see x power 4 coefficient has to be the coefficient of x square into x square, right? X square from the first one, x square from the second one. So here we have ax cubed, ax square into x square. So a has to be equal to 3, right? A has to be equal to 3. Now we know x cube. X cube is formed by x square into x coefficient and x into x square. What I mean to say is x square from this one, x from this one, x from this one, x square from this one. So that is the only thing which will get us to x cube. So in some sense, so 10 should be equal to x square into x here, which is 1 into b plus x here into x square here, 6 into a. Now a we know to be 3, so this is b plus 18. So b has to be minus 8. So we know b as well. C, how do we find? I mean, just multiply the constant terms. So, so what was it? 10C is equal to minus 30. 10C minus 30, that would mean C is minus 3. So the other polynomial, other factor of P, so the other factor of P of X is 3x square minus 8x minus 3, right? So what are the roots? Other roots. So we have written one root here. This is another root, and other than these two, the other roots would be x is equal to 8 plus minus square root of, what is the discriminant? 64 minus 4 into 3 into minus 3 divided by 2 into 3. So, okay, so that is 8 plus minus square root 64 plus 48. Is that it? Yeah, 12 into 3, 36. Oh, sorry. By 2 into 3. This is 10. So other roots are x is equal to 8 plus 10 by 6. 8 minus 10 by 6. So it is either 3 or minus 1 by 3. That's it. So I hope that clears this question. Yeah. So on to the next one. Please again pause the video and try this question on yourself, by yourself. I hope you have done that. So suppose f of x is equal to this and c and d are real numbers. Okay. Prove that if c is greater than 1 by 3, then f has exactly one real root. So what happens? What happens when a function or a polynomial is given to be cubic? So in a cubic, uh, either it has all three real roots. So cubic with real coefficients, I'm talking, right? All three real roots, or it can have one real root and two complex roots, right? And our question is asking exactly one real root. That means we want this to happen. So when does this happen? So if you look at the graph of it, if a cubic has all three real roots, it will be like this. But if a cubic has only one real root, something like, how would I say? Okay, so one case is x minus 1 whole cube equal to 0, this kind of a thing, right? This definitely has one root, but that does not mean it doesn't have other real roots. So something like x minus 1 into x square plus 1 equal to 0. So this is a cubic, yeah? This is a cubic, but it has only one root. So the graph of this would look something like this. It will be a strictly increasing odd function. Strictly increasing odd degree function, right? And it will be intersecting only at 1. Both will be intersecting only at 1, but you see the difference? I hope you do, right? So one thing you should be immediately able to observe is that this is strictly increasing. Yeah. Whether it is like this or this, both are strictly increasing. Both are valid. Okay. So strictly increasing meaning f dash of x has to be strictly greater than 0, which implies here what is f dash of x? F dash, how would I find it? Yeah, f dash of x would be 3x square plus 2x plus c. Yeah, that would be 3x square plus 2x plus c greater than 0. When is a quadratic strictly greater than 0? Yeah, this is positive. No, the coefficient of x square is positive. So that means it would be something like this. It is not even touching. Yeah. So what is it? That means D has to be less than 0. A is greater than 0. Yeah, this graph is A is greater than 0. And this is minus D by 2A or 4A. This has to be greater than 0. So D has to be less than 0. So what is D? D is equal to 2 square minus 4 into 3 into C. Yeah, this is less than 0. That means 4 minus 4 into 3C is less than 0. So 1 minus 3C is less than 0. In other words, C is greater than 1 by 3. So if C is greater than 1 by 3 given, it has exactly one root. So one root happens only when, these are double implications. I hope you see that. This implies that, and other way around, you can go back here. This will imply that this is greater than 0, and this will imply that this is strictly increasing, and this will imply that it has only one real root. Understand? So I hope you understood how we do this. Yeah, that's it. Let's go. This is the final question for today, I think. Yeah. So just have a look at it and try to do it by yourself. Pause the video and try. Now, it is easy to find a polynomial root 2 plus 1, root 2 plus I as root, and p of x having real coefficients. Why is this not working sometimes? Okay. Having real coefficients. How do we find that immediately? Like if this is a root, we want real coefficients, what do we need to do? The other root has to be root 2 minus I. So root 2 minus I, root 2 plus I. So we can find a quadratic. What is a quadratic? X square minus the sum of the roots, 2 root 2 x plus the product of the roots, 2 plus 1, 3. This is a polynomial which has these roots. So this can be p of x. Right? So A is easy. Let's go to B. Find a polynomial q of x with rational coefficients. Here we just needed real. Here we need rational. Root 2 also cannot work. Right? So having least degree such that this is a root. So one thing is we can have x square plus 3 written as 2 root x, and we can say that if I square the whole thing, this becomes rational, right? So x square plus 3 whole square is equal to 2 root 2x whole square. This happens to be 4 times 2, 8x. So if I take my q of x to be x square plus 3 whole square minus 8x, this is rational coefficient with square root 2 plus I as a root, right? But we also need to show one more thing. It must have least degree. How do we prove least degree? So definitely we have seen that a square does not work. Quadratic does not work. So let us assume, suppose uh, a cubic polynomial has root 2 plus 1 plus I as a root. Cubic polynomial with rational coefficients. Rational coefficient. Right? That means the cubic, let's say ax cube plus bx plus c, bx square plus cx plus d, has to be, since one of this is a root, so x minus root 2 minus I, x minus, okay, some a into that. Let's take, monic polynomial, so we don't have to worry about that. X minus root 2 plus I, and let's say it has some real root. Yeah, let R be a real root. Okay, so how would that look like? That would look like x square. Okay, what was this? X square minus 2 root 2. Okay, did I take plus? Minus 1. Minus 2 root 2x plus 3 into x minus r. So how would that look like? X cube um, minus, so I want x square, so x into, so minus r plus 2 root 2 whole x, right? And yeah, I think that's pretty much it. That's what you'll get, minus r minus this. Yeah. And what's the coefficient of x? The coefficient of x will be, so suppose I multiply these two, so I'll get plus 2 root 2 r, and suppose I multiply these two, so I'll get plus 3 into x, and the last term would be minus 3r, right? So comparing the coefficients here, I hope you remember that b, c, d are rational numbers. That is the assumption. Our assumption is a cubic polynomial with rational coefficients, right? So that means if I comparing the coefficients, this has to be given that b is equal to r plus 2 root r, 2 root 2, sorry, and c has to be uh, 2 root 2 r plus 3, right? So is this sitting together? And 3r has to be d. So let's say I plus minus, I take care of that. So 3r has to be d. Here it gives me that r is equal to d by 3. So r has to be rational. But r is also this, b minus 2 root 2. So clearly this is irrational. Why is this irrational? Because b is rational and this is irrational. So overall r is an irrational. So this is a contradiction. Contradiction. Is that understood? So okay, so this is important to note, and once you noted that, now it this contradiction to what? Contradiction to this assumption. This is assumption is wrong, right? Okay. Now there is a C part. Show that any other polynomial f of x with rational coefficients and this has q as its factor, obviously. So I mean that's easy to see actually. Let's say f of x has, I mean the degree of f of x has to be greater than or equal to degree of q, right? Degree of q being equal to 4, right? Because q was by default the least degree such that this has a root. So that will imply that f of x can be written as some q of x into a of x plus b of x, yeah, where degree of this is strictly less than 4, right? Obviously. But if you take f of, and all are rational coefficients, all are rational coefficients, all are rational coefficients. So, but if you take root 2 plus I, you will get this is 0, root 2 plus I, this is 0, equal to, and this is also 0. But 0 is equal to what? B of root 2 plus I. But this is of degree less than 4. And we know that there exists no polynomial with degree less than 4, such that no non-zero polynomial, at least we can assume, that such that this is a root. So this has to be identically equal to 0. B has to be identically 0. So that means Q of x is always a factor of f of x. So that proves it. Um, so that's it. That's all for today. I hope you enjoyed watching it. Uh, Take care. Bye.